Hello everyone. In this video, I'm going to talk about the probability distribution, especially the discrete probability distribution. And I will show you how to calculate the mean, standard deviation, and variance. So first of all, the probability distribution is following. This is an example. When you have a random variable x, and this random variable is a discrete random variable, in the case, you have the probability of x. Let's say that x is a 1 and 2. And probability x when x equals 1 is 0.6. And probability when x equals 2, that is a 0.4. And this is a probability distribution. Why is that? First, the probabilities 0.6 and 0.4, both of them between the 0 and 1. So probability of the x is between 0 and 1. And second, summation of the probability equals 1. So what I'm saying is that 0.6 plus 0.4 equals 1, right? So it satisfies the probability distribution. And this is a discrete probability distribution because we have a 1 and 2. It's not continuous. There are only the two possible outcomes, 1 and 2. Now, with this example, we can calculate the mean. So the mean, we denote the mu or the E of the x. This one is the expectation of the x. And the formula is the following. This expectation of the x or the mu is summation x times the probability x. So the outcome times the probability x, and then you have to calculate the summation of them. In this example, you see that the first x is x equals 1, and the probability x equals 1 is a 0.6. So 1 times 0.6 plus, when x equals 2, the probability is a 0.4. So it turns out the 0.6 plus 0.8 is a 1.4. The mean is a 1.4. Very straightforward. What about the standard deviation? So standard deviation, we denote sigma, or you can denote the sigma of the x. This sigma of the x, the formula is the following. Summation x minus mu squared times the probability of x. And there's a bracket. Okay. So how can we use this formula? Well, since we already calculate the mean, the mu is a 1.4. This is how you use a formula. Oh, I forgot to take a square root. So here we need to put the square root. When you don't have a square root, that is a sigma squared, which is the variance. Now the standard deviation is the following. The first one is a 1 minus mean is a 1.4 squared times the probability 0.6. Be careful, I didn't square the probability. It's just probability x. And then plus, because we have a summation notation, plus 2 minus 1.4 squared times 0.4. Then you see that this one is negative 0.4 squared times a 0.6 plus 1.6 squared times a 0.4, then you will get the number. Just want to make sure you calculate this one, then you can use a calculator or the Excel. So let me show you how to use the Excel and calculate this one. Okay, so you see that here I pop up the Excel. So I put the equality and I'm calculate parenthesis negative 0.4 close the parenthesis power of 2 times 0.6 plus open the parenthesis 1.6 close the parenthesis square times 0.4, and I got 1.12. That's the answer, standard deviation. So that's how you calculate the standard deviation and the mean. Now, you may not understand the meaning of this mean and the standard deviation for this discrete probability distribution. So let's solve another example. So take a look at this one. College students are randomly selected and arranged in groups of 3. And with this example, the random variable x is a number in the group who say that they take one or more online courses. Determine whether a probability distribution is given. If probability distribution is given, find its mean and the standard deviation. So the question asks you to check whether this is a probability distribution. So like I said, you need to check whether the probability is between 0 and 1. Well, yes, it turns out everything is between 0 and 1. There is no probability which is a negative. There's no probability which is a greater than 1. So it satisfies the condition. Now, I need to check whether the summation of the probability equals 1. So let me just copy and paste this probability distribution. So I'm just copy and paste this table like this. The first column is a probability, the x, and then the second column is a probability such as 0.107. Second one is a 0.356. And then the third one, when x equals 2, is a 0.391. And then the last one is a 0.146. Now, given this, I want to calculate the summation of these probabilities. So, which is summation of these the probabilities equals 1, which means this is a probability distribution. Okay, so I check the first condition. Now, I want to calculate the mean and the standard deviation. So, same as before, the mean mu or the E of x, the formula is summation x times the probability x. So by hand, you can calculate this way: 0 times 0.107 plus 1 times 0.356 plus 2 times 0.391 plus the last one is when x equals 3, 3 times 0.146. Then you can find the mean. Well, with the Excel, what I can do is the following. So here I choose another cell and I calculate the multiplication of these two. So x, the outcome, times the probability. And you do the same thing for the other column. So here, I want to fill up this table. So you can use the automatic function. Give me 1 second. So this cell is, I calculate the multiplication of the A5 cell in my case times this one. There is a way to auto-fill up. Give me 1 second. A5 times B5. It has to be B5, so this 0.107. Autofill. So which means that I calculate 1 times 0.356, that's a 0.356. 2 times 0.391, that's a 0.782, so on and so then I calculate the summation of these numbers. Then it gives me the 1.576, that's the mean. So here I'm using the Excel and I found this mean, which is a 1.576. Of course, you can calculate by hand, but it's a little bit annoying to calculate this one. So that's why I prefer to use the Excel. Now, you will see the benefit, especially when I calculate the sigma, the standard deviation, which is the formula is the same as before, square root, summation, bracket, x minus mean squared times the probability x, and close the bracket. So in this example, because we calculate the mean, which turns out the 1.576, so the sigma of the x is the following: square root 0 minus 1.576 squared times the probability, which is a 0.107, plus 1 minus same mean 1.576 squared times the probability, which is a 0.356. And you do the same thing. 2 minus 1.576 squared times the probability 0.391 plus 3 minus 1.576 squared times the probability 1.146. And keep in mind that everything is inside of the square root. Because I have no space, that's why I wrote down this way. But anyway, I want to exaggerate. I didn't square the probability. the thing that I squared is x minus mean, okay? 0 minus 1.576, 1 minus 1.576, so on and so forth. And these terms I squared, okay? And it's a little bit annoying to calculate this one, but there's no shortcut, which means here, I can do this way. So I first calculate 0 minus, so I click this cell equal 1 minus 1.576, okay? You can put the dollar sign before and after the alphabet D. So if you put, when you put the dollar sign, so before and D and then the right after the D, and you put the enter. Oh, wait a second. So it's not the D cell. This one is a C. I choose a wrong cell. So A5 minus 1.576, that's a C9 cell. So I put the dollar sign before and after C, like this. Then I basically fix this C9 cell. And you do the same thing. You autofill the following observation. I mean the 1 minus 1.576, 2 minus 1.576, so on and so forth. And you drag this one and then autofill. Okay. And then the next thing is you have to square these values, which means you want to calculate negative 1.576 square. Okay. And you do the same thing for the negative, negative 0.576, and then this 0.424 and 1.424. So what I need to do is, same as before, I drag this one and then the autofill. I calculate automatically. And so what I did is following, I calculate these things. So for example, here, instead of square root, I got 2.48 dot something times the probability 0.107. And then the second one, it turns out the square root of that parenthesis is a 0.331, and then times the probability 0.356. So I need to calculate this one. So which means here, put the equality, this square thingy times the probability, which is the 0.107. So in my case, E5 cell times B5 cell. And then I want to calculate this, 0.331776 times the probability 0.356. So what I need to do is the same as before. I autofill the value. And finally, the next step is, I forgot to put the summation. And then I just need to calculate the summation of this number. So put the equality, summation of these numbers, these four numbers. I got the standard deviation, which is 0.750224, but that's not the end. I have to take a square root. So put the equality SQRT of this number. Then finally, I got the standard deviation, which is 0.8662 up to 4 decimal places. That's the answer. So I believe that you remember the meaning of the mean and the standard deviation. Mean is the average, right? The central tendency. And the standard deviation is a measure of the variation, how far from the center. So if number is large, that means it's far from the center on average. If it's small, then the observations are centered to its mean. Now, let me give you another example. So this is the very helpful example to understand the discrete random variable, especially this is for the stock returns. So here, first of all, you can see that this is a discrete probability distribution. You have 4 different outcomes: recession, slow growth, moderate growth, and fast growth. And each economic situation, you have the probability. And turns out the probability is always between the 0 and 1. And summation of this probability. So 0.1 plus 0.3, 0.4, 0.4 plus 0.4 is 0.8, and then plus 0.2 is a 1. So the summation of the probability equals a 1. Okay? That's a 1, which means that I just verify this is a discrete probability distribution. And then we have 2 stock returns. One is a stock X and the other one is a stock Y. Now, this question asks you basically the same thing. Expected return for stock X, that means that you need to calculate E of X, expected return for stock X. That's the same as a mu of the X. So to differentiate the X and Y, I denote the mu of X. And then the following question asks you to calculate the expected return of the Y. And this one is a mu of the Y. And after that, the question also asks you to find the standard deviation of the X and standard deviation of the Y. Now, let's calculate this mean first. So by hand, you can set up the equation as following. Point 1, so because that the formula is summation X times the probability X, you can do this way. So the outcome in this case, negative 50 times the probability 0.1 plus 30, the stock return is 30% times the probability 0.3 and 100 times 0.4 plus the last one is 150 times the probability 0.2. So here you can calculate this probably it's this algebra using the calculator. So I need a space. The last one is a 150 times the probability 0.2. Now, given that, well, of course, that you can do the same thing. Let me write down this way. So negative 50. So this is the first column is a stock return of the X, negative 50, 30, and 100, and what is it, 150? And stock Y, negative 200, 40, 140, and then 210. And then the probability, I write down the third column, the probability 0.1, 0.3, 0.4, 0.2. I mean, you can put the probability first, but it's not that important as long as you know that which one is which. So here, when I calculate the mean of the X, I first find the multiplication of these two, the probability and outcomes. So negative 50 times the probability 0.1, so on and so forth. And you do the same thing. So autofill, and then find the summation. So the summation of these numbers is 74. So mean of the X is a 74, which means that on average, you can expect that the stock return of the X is a 74 because you don't know that whether the economic situation is a recession, slow growth, moderate growth, or fast growth. By having this mean, you get to know on average, all right, so if I invest my money into the stock X, then your expected return is a 74. And of course, you can do the same thing for the stock Y. So here, let me skip the writing down the equation. I mean, you know that here, basically same step, negative 200 times the probability 0.1 of 40 times a 0.3 plus 140 times 0.4 plus 210 times a 0.2. So that's why once you understand the concept, you may not need to write down the equation. But to avoid a mistake, why not? You want to write down the equation like that. But probability times the outcome, and you do the exactly same step as X, and then you calculate the summation of these multiplications. Then it turns out stock return of the Y is 90. So just checking the mean, E of X, expected return of the X is a 74%. Expected return of the Y is a 90%. It seems like the investing into the stock Y is a much better because 90% is greater than 74%. But we have to check the standard deviation of the X and Y because this standard deviation captures the riskiness of the stock X and the Y. If the standard deviation is large, that means that it fluctuates a lot. If the standard deviation is small, then it does not fluctuate that much. That means that it's relatively safe the stock. Okay, so we use the same formula and we want to calculate the standard deviation of the X and standard deviation of the Y. So because I need a space, let me calculate the standard deviation of the x first, and then I will show you how to calculate the standard deviation of the y, even though it's basically same. So the formula I told you is square root summation x minus e of x, and e of x is same as a mu of the x squared times the probability x. So let's do it. All right. So here, I'm gonna calculate the x minus mean of the x. So which means here put the equality -50 minus mean was a 74, right? So in this case, let me just put the number 74 instead of the fixing a cell. And then you do the same thing for the 30, 100, 150. You calculate the difference from the 74. So 30 minus 74 is a -44, 100 minus 74 is a 26, and 150 minus 74 is a 76. And then the next step is you have to square this value, right? I'm using the formula, so square of this value, and do the same thing for the other values as well. And then what's the next step? You need to calculate the multiplication with the probability. So this 15,000 something times the probability, which is a 0.1. So I think give me 1 second. It's better to do it with the another column. So the 15,376 is squared of the parenthesis. I want to keep the number, but here, this time, I want to find the multiplication, this number, times the probability 0.1. And then this number, 1936, times the probability 0.3. And you do the same thing, 676 times the probability 0.4. And then 5776 times the probability 0.2. And then find the summation. Then finally, you get the variance because the question asks you to calculate the standard deviation, right? Which means that you need to take a square root. Square root of this number is 59.53. So let me write down up to 2 decimal places 59.53. Now, I want to calculate the standard deviation of the y as well. So here, do the same thing. This -200. So pick up a cell. This -200 minus mean. And then the mean is 90. And you do the same thing. 40 minus 90. And then 140 minus 90. And then the last one is same, 210 minus 90. And then what's the next step? You square. So -290 squared, and then 50 squared, sorry, 50 squared is 250. Sorry, 200, 2500. And then the last one is a 120 squared that I got 14400. All right. And then the next step is I multiply by the probability. So this 84,100 times the probability 0.1, and then 2,500 times the probability 0.3, this 2,500 times the probability 0.4, and then the last one is 14,400 times probability. And then you find the summation of these numbers, then you get the variance. The summation of these numbers, 4 numbers, I got, so I need to close the parentheses. So I said 13,040, and then you take a square root of this number, then you get the variance. So here, SQRT parentheses, and this one. So 114. 114.19. So what do you see? Well, we calculate the mean and the standard deviation. If you just compare the means, then it seems like y is much better than the x because it gives the higher return, but it turns out standard deviation of the x is much smaller than the standard deviation of y. The reason that this one is high means that there is a high risk. So you can say that there is a higher risk and higher return. So it's up to you. If you prefer to have the high risk and high return, you may want to invest your money into the stock Y. Otherwise, you are the risk averse person. You don't want to take that high risk, then you may want to invest your money into the stock X, which has a smaller standard deviation, but it has a smaller mean. Thank you.